Okay, so welcome back. So now I hope you've learned that the interrelationship between the alpha and the beta, that if you keep the sample size constant, the smaller you make alpha, the bigger a beta becomes, and vice versa, and that as you make your sample size bigger, you increase the power. Let's go back and let's now look at the two sample comparison of means. Let's recall when we first looked at this, and what were we looking at? We were looking at total cholesterol level, and we were looking at the two groups hypertension. So for example, let's bring all that back, hypertension, and let's summarize the Todt-Scholl 1. That's what we were looking at, and let's see. So there we are. We have the two groups with a mean of the no hypertension was 227, 228 say, and the yes 240, and the standard deviation was about 44, 45. What is the mean one? So let's say the mean one is for the no, and let's say the mean one is 228, and the mean of the second one is 240, and the standard deviation of the first, let's give this one standard deviation of 43 and give this one a standard deviation of 45. Okay, now let's look at our options. Let's say compute the power significance level of 0.05. Let's leave that the way it was. Two-sided test. Now let's say compute the sample size. First let's do compute the sample size to get a power of 0.9 and submit that. And what do we get? We get that if we want to detect this smaller difference, let's say 12 units, then when the standard deviation is 43, we're going to need a sample size of 283 from the first group and 283 from the second group. Right, so now with the two sample, the role of the postulated is going to be how far apart do these two means have to be in order to have the power that you desire, and then to do your sample size. So when the standard deviation is roughly in the 40s, to detect a difference of 12, you're going to need a sample size of 283 in each, so that's about 560. It's close to 600 to be able to spot that difference with 90% power. What if we want to spot a bigger difference, say between 228 and 250, then we will need a much smaller sample size, 85. Okay, so I'm going to leave you now to let you experiment and explore what happens to sample sizes when you explore the changes in these parameters of the system. Now, this sample size calculations is very important when you're designing a study to see if you're going to take samples of size 10 from each, you're not going to spot a small difference with any degree of power. That's where the art comes in here, where you make your choices. How big a sample do you need to detect what, with how much power, etc.